Welcome you all. Today we are going to discuss one more exercise in a combustion and fuels. This exercise also comes under the alternative fuels. The question is, the calibration of an air-fuel ratio analyzer is to be checked by using the following gas mixture, which represent the dry products of combustion from a hydrocarbon fuel. The constituents and the respective volumes are given. The constituent is methane 550 parts per million, hydrogen H2 3.23%, carbon monoxide 6.20%, carbon dioxide 12.29%, then nitrogen balance. Calculate and comment on the values of A. The molar hydrogen to carbon ratio of the fuel. B. The gravimetric air-fuel ratio corresponding to these products. C. The gravimetric stoichiometric air-fuel ratio and the equivalent ratio. D. The water gas constant. Now, solution, they given that the products of combustion, that is methane CH4 550 ppm. So we have to convert into percentage by volume. That is 1% by volume is equal to 10,000 ppm parts per million. So that we can get this is equal to 0.055. So CO2 3.23, carbon monoxide 6.20, carbon dioxide 12.29%, assuming 100 moles in the exhaust gases. So these product of combustion are methane 0.055, then 3.23 for hydrogen, 6.20 for carbon monoxide, 12.29 for carbon dioxide. The summation is 21.775 mole of exhaust gases. The remaining balance is the nitrogen. So 100 minus 21.775, we get 78.225 mole of nitrogen. Now the combustion equation is, assuming that CaHb is the hydrocarbon fuel plus Y amount of O2 plus 3.76 N2 produces 0.055 methane plus 3.23 mole of hydrogen plus 6.20 carbon monoxide plus 12.29 carbon dioxide plus 78.225 nitrogen. Now we know that any hydrocarbon fuel bond with an air to produce water as vapor, assuming that M mole of water present in the product of combustion. Now when you are making a carbon balance, in the left hand side A is equal to 0.055 methane plus 6.20 for carbon dioxide, 12.29 for carbon dioxide. That is A is equal to 18.545, assuming this is equation 2. Now, when we are making a H balance, B is equal to 4 times 0.055 plus 2 times 3.23 plus M into 2 times for water. When simplifying, we get B is equal to 6.68 plus 2M, equation 3. Now, when you are making a O balance, 2Y in the left hand side is equal to 6.20 for carbon monoxide, then 2 into 12.29 for carbon dioxide plus M. While simplifying, we get 2Y is equal to 30.78 plus M. This is equation 4. Now when you are making N balance, we said that 2 into Y multiplied by 3.76 is equal to 78.225 multiplied by 2. We get Y is equal to 20.080. This is equation 5. Now apply 5 into equation 4. We get 2 into 20.8 is equal to 30.78 plus M. Then M is equal to 10.82. This is equation 6. Now apply 6 in 3. We get P is equal to 6.68 plus 2 multiplied by 10.82. B is equal to 28.32. This is equation 7. Now from this analysis, we can find that CaHb. The fuel is C 18.545, H 28.32. That is, we can write CH 1.527. That means that CH 1.527. So that if the fuel has C X mole of C, it will be combined with 1.53x amount of hydrogen. So the hydrogen to carbon ratio is equal to 1.53:1. Answer A. Now the question B is gravimetric air fuel ratio. We know that the amount of Y is equal to the air fuel ratio on mole basis is equal to 20.8:1. That means that 20.8 mole of air per mole of fuel. So here air fuel ratio on mass basis or gravimetric basis is equal to 20.8 multiplied by 1 plus 3.76 multiplied by 29 molecular weight of air, and here 1 mole of fuel, that fuel is equal to 12 into 18.545 plus 28.32 multiplied by 1, we get 11.44 kg of air per kg of fuel. This is answer B. Now the question C is stoichiometric gravimetric air fuel ratio. So this stoichiometric air fuel ratio of the fuel, that is C 18.545 H 28.32, air fuel ratio stoichiometric on mole basis is equal to 18.545 plus 28.32 over 4, that is equal to 25.625 mole of air per mole of fuel, and stoichiometric air fuel ratio on mass basis or gravimetric basis is equal to 25.625 multiplied by 1 plus 3.76 for air molecular weight of air 29 over 1 kilomole 12 into 18.545 plus 28.32 multiplied by 1, we get 14.10 kg of air per kg of fuel. First part of answer C. Then the equivalent ratio phi is defined as stoichiometric air fuel ratio over actual air fuel ratio, that is equal to 14.10 divided by 11.44, that is equal to 1.23. This is second part of answer C. Now the question D is water gas constant. The combustion equation is C 18.545 H 28.32 plus 20.8 O2 plus 3.76 N2 produces 0.055 CH4 plus 3.23 H2 plus 6.20 CO plus 12.29 CO2 plus 10.82 H2O. Now the water gas reaction is CO2 plus H2, it will give CO plus H2O. Then water gas constant K is equal to P dash of CO multiplied by P dash of H2O over P dash of CO2 multiplied by P dash of H2. That is, we know from our equation CO is equal to 6.20, then H2O is equal to 10.82, CO2 is equal to 12.29, H2 is equal to 3.23. We can get K is equal to 1.6899, that is equal to 1.7. Answer D. Thank you.
Subscribe to our channel, like if you're satisfied, and share because it may be useful to someone.